Now we're going to find the best fit line and the slope of that best fit line. So whenever you have some points that you need to graph and find a best fit line of, the question is, how do you do that? Like, where does this thing go? And a lot of people will say, well, you just connect the first dot and the last dot. And if I do that, if I put my ruler over the first dot and the last dot there, then I get 2 points that are below the line and 1 that's above the line. That's not too bad, but it's not always the best way to go. You're trying to find the best possible line that fits the points, and then has an equal number above and below it. So I think if we were to go a little bit like so, that would give me 2 points above the line and 2 points below the line, and everything would be pretty close. So let's give that a shot there. So let's say that's my best fit line. If I want to find the slope of this thing, there's a couple different ways I can do that. If you're in a math class, your math teacher may tell you that the slope is y2 minus y1 over x2 minus x1. Or your teacher may tell you that slope is equal to rise over run. In both cases, they're actually the same thing. It's just different language to express the same idea. So what I try and do in this case is I want to find my best fit curve, and I want to see where that best fit curve goes through some easy data points. So do you see how my best fit curve goes right through like a cross hatch right there? So I'm going to use that one, and I'm going to look and see if that occurs anywhere else. And it does pretty close right here, but I'm trying to find 2 points that are fairly far apart, and I don't really see that. So what I'm going to do instead is look for another easy data point, which could be down here, like right here, but that one's not quite 0. So what if we chose this one? And I'm choosing it because it looks like it fits halfway between these 2 lines, and it's right on that line. So let's say I pick these 2. You can pick any 2 on the graph that you wanted. I just happened to pick these 2 for the reasons I explained. And we need to label these things 0.1 and 0.2. It actually doesn't matter whether you call this one 0.1 or 0.2 or this one 0.1 or 0.2. You just have to like name them and stay consistent. So I did this one first, so I'm calling it 0.1, and this one's 0.2 because I did it second. All right. So if I wanted to do this top method, I would take my y value for the second point. So I would come over from my second point all the way over here, and that would be 18. So I would get 18 minus, and then the y value for my x, I come over here. Oh, that's in between. So that's between an 8 and a 10. So it must be a 9. So 18 minus 9. And I have to do the same thing with the x's down on the bottom. So this is my x-axis, and this is my y-axis. If I come straight down like so, ooh, I'm in between here. Well, I know this is 40 and this is 45. So where is this point? You get to guess. I can't mark you wrong for guessing because you're guessing. Everyone knows you're guessing. So to me, that looks like it could be, well, let's see, halfway between 40 and 45 is 42 and a half. So that kind of looks like 42 to me. So I'm just going to call 42. If you called it 41 or 43, that's fine. That's okay. We'll live with it. And I'm going to do the same thing with my x value. And because I could put it right on a cross point there, I know that this one is easy. It's 20. So if I do the math on this, 18 minus 9 is 9, and 42 minus 20 is 22. And now I'm going to take my calculator right here, and I'm going to do 9 divided by 22, and I'm going to get 0.49. Now, since I did my y's in miles and my x's in minutes, my slope actually has a unit. It's 0.49 miles per minute. 0.49 miles per minute. But what if I wanted to do rise over run? Well, when you do rise over run, you actually draw a triangle between your 2 points. So I'll draw my rise part of my triangle. And then I'll draw the run part of my triangle. So here's the rise. And here's the run. And I rose from 9 up to 18. Now, some of you are going to want to do this. You're going to want to say 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 as my rise. In this case, you can do that because the scale counts by ones. 1, 2, 3, 4. But do not do that in general. That's a bad practice. You want to find your rise because you went from 18 and 9. So 18 minus 9 gives me a rise of 9. Because if we did that in the run and we said, well, I'm going to run 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 and a half. No, you don't. Because 20 plus 8 and a half, well, that would be here. But you're way over here. So you need to follow the scale. So we called this thing 42 last time. So I'm going to repurpose that too and call 42. And if I ran from 20 to 42, how far did I run? Well, 42 minus 20 is 22. So my run is 22 and my rise is 9. Well, look at that. My rise is 9 and my run is 22. Like I said before, whether you do y2 over or y2 minus y1 over x2 minus x1 or rise over run, you get the same answer. Now I made this triangle. Could I make this triangle down here? It seems like things would be a little different. But remember that you always run horizontally and you always rise upward vertically. And we're going to run from between 20 and 42 again. So this is going to be 22. And I'm still going to rise from 9 to 18. So my rise is still going to be 9. And I'm still going to have the same slope. So whether you do y2 minus y1 over x2 minus x1, or this triangle to do a rise over run, you will get the same answer. Now, in a previous video, we took a look at this data right here for our mass and our volume. We drew our best fit line during that video, and now I want to find the slope. So again, I encourage you to find a data point where the best fit line goes through like a cross so that the data is easy to find. It's easy to read. And if you look right here, the best fit line goes right through that cross section right there. And then we could come up and that happens again here, and it happens again here. So it actually doesn't matter which of these points we use, but the farther apart they are, the more accurate your answer will be. So I'm going to take this bottom one and this top one, and just so that I can show you that it actually doesn't matter, I'm going to call this one 0.2 down here, and I'm going to call this one 0.1. Why? Because I'm trying to show you that it doesn't matter which point you call, it's all going to work out. So let's do rise over run on this one to start with, just so we can do everything backwards this time. And I'm going to rise from this point up to here. So here's my rise, and my run is going to be over to the right I'll run horizontally across there. So here's my run, and here's my rise. And let's do our run first. So our run went from this line down here, which is 50, right? So we're going to run from 50 over to this point, and this point, if I come down, is 140. So our run is 140 minus 50. And if you put that in your calculator, that's equal to 90. Now, we ran this direction, so we should come over here and say that I ran 90 milliliters because that's the direction I was running in. Now, I need to rise. So I'm going to rise from this point. Ooh, that's halfway between 4 and 5, so that's a 4.5. And I'm going to rise up to, this point in the middle of nowhere. So halfway between 12 and 14 is 13. And halfway between 12 and 13 is 12.5. So my rise will be 12.5 minus 4.5, which is 8. And I'm rising in grams. So if I take my slope, it's equal to rise over run, or it's equal to my rise of 8 grams over my run of 90 milliliters. And so if I do the calculation on this one, 8 divided by 90 turns out to be 0.089 grams over milliliters. So there is my slope. Okay, the only way to get good at these things is to continually do them. So keep practicing and you'll get better at it.